Okay, now we're going to work on chapter 2. I'm doing problem 2.12. He asks you to do 211 and 213, both of which have answers. So for 2.12, it's asking us how many significant figures are in each of the following numbers. And since a lot of 130 students, a lot of chemistry students have problems with significant figures, so we're going to go a little slow on this one and break it down, and hopefully you can come back and rewatch this video. I'm also going to share another video that I really liked that helped me with significant figures. So what I have up top here is not mine. I got this off the internet from the video that I like. And I'm going to teach you what are significant, or I'm not teaching you, but we're reiterating what PK taught us in class. What are significant and what are not significant numbers. And in this case, it's really straightforward. Leading zeros, as you see here, are not significant. In fact, those are the only things that are not significant in this number. So leading zeros are the only thing that are not significant in this number. We see that we have a zero here and here. This is called an in-between zero, and it's significant. And all trailing zeros are significant. So even if we added a whole bunch of zeros to these numbers, they would still be significant. Okay, so here's what I'm going to do. I'm going to highlight leading zeros, not significant. I'll write that up there. Should have done it in blue. Not significant. Now, not significant doesn't mean not important, because they're important, but they're not significant for this case. All right, so A, we have a number 20.60 milliliters. All right, so do we have any leading zeros? We do not. Every other number is significant, so we have, let's do a highlighter. We have this number, 1, 2, 3, 4. These are all significant. Right here, we have an in-between zero, which is significant. And right here, we have a trailing zero, which is significant. So for this number, we have 4, we call them sig figs, or you can put SF, for significant figures. Okay, for B, we have no leading zeros, so every number is significant. We do have an in-between zero right here. We don't have any trailing zeros, and we know that all non-zero digits are significant. So we just count. We have 1, 2, 3, 4, 5, 6 significant figures. All right. For our next one, 4.00. It's a little tricky, isn't it? Well, do we have any leading zeros? We don't. Do we have any in-between zeros? We don't. Do we have any trailing zeros? We do. So these are called trailing zeros, and they are significant if they come after a decimal. And we're going to see that in the next problem. So as long as the trailing zeros, let's make a note of that, come after the decimal, and after a non-zero digit. Then they're significant. All right, so do these zeros come after a decimal and a non-zero digit? They do, so they are significant. So we have 3 significant figures for 4.00 meters. Okay, D, 20 degrees Celsius. I wrote my degree in the wrong place, my bad. Okay. Do we have any leading zeros? We don't. Do we have any trailing zeros? We don't, because remember that trailing zeros come after a decimal and a non-zero digit. So here's where it kind of can get a little bit tricky. We only count the non-zero digit, which is 2. The 0 after that 2 does not come after a decimal, so it's not a trailing 0, so it is not significant. This tells us we have one significant figure. Does that mean that the 0 is not important? It doesn't. The 0 is important, but it's not significant. All right, here's another example. This has no decimals with trailing zeros. It doesn't have any leading zeros, right? There are no zeros before the 6. So it starts out with a non-zero digit, and we count that. Let's look back up at our reference. When we have a 0 between 2 or between any type of non-zero digit, those are called in-between zeros, and we count them. They are significant. So let's go ahead and underline those zeros in orange. Okay, let's ask ourselves, does this 0 come after a non-zero digit, or is it in between a non-zero digit and another non-zero digit? It is, so it's in between 6 and 8. What about these zeros? Well, they're not after a decimal place, so they're not trailing zeros. And there are no other non-zero digits between the 8 and this last 0. So these 5 zeros are not significant. I'm going to underline those in blue. Those are not significant. So the only numbers that we have that are significant, let's highlight those, are going to be the 6, the 0, and the 8. So how many significant figures do we have here? We have 3. Now, are those zeros important still? Yes, they are just not significant. What if we changed the number to 60800000001? Well, now that changes everything, because this digit is a non-zero number and it is significant, and it makes all of these zeros right here, now they're in between 2 non-zero digits. So now they are significant, and that would completely change our significant figures. But as it stands, we just have the 3 significant figures. Okay, let's look at one that's in scientific notation. These can get a little bit confusing, right? There's a couple of ways to look at this. Let's do this. Let's talk about what isn't significant in a scientific notation. So what isn't significant, remember up here when we had a standard number, we had these leading zeros, we highlighted that in blue, those are not significant. So I'm going to highlight in blue what's not significant, what we don't look at, what we don't even consider. We don't even look at this number. We don't need to worry about what's in that number to talk about significant figures. The only number that we want to look at is this number right here, whatever comes before this. All right, so let's talk about it. Are there any leading zeros in 5.0? There are not. We know the 5 is significant because it's a non-zero number. But what about the 0 after the decimal? Let's go back up to our number. Trailing zeros come after a decimal and a non-zero digit. The 0 comes after a decimal and a non-zero digit, so it is significant. Both of these numbers are significant. So we have 2 significant figures. What if I added more zeros? Would I count them? I would. So now we have 1, 2, 3, 4, 5 significant figures. Remember, when it's in scientific notation, we can ignore the 10 to the power of number. Just for fun, let's write out that number in standard notation. So remember, when we have a negative number as our exponent, that means this number is going to get smaller when we write it in standard notation. So 5.0, and we have -3, so we're going to go to the left 3 decimal places. 1, 2, 3. Here's our decimal. Put zeros here. Let's talk about this number. So our scientific notation number has 2 significant figures. Let's talk about our standard notation number and see if it matches. Hint, it should always match. Let's redraw it so it's not so messy. 0.0050. All right, let's go back up to our example. So leading zeros that come before a non-zero digit, but not after. There is no non-zero digit preceding these zeros, correct? So 0, 0, 0. Those are not significant. So let's come back down to our new number. And let's highlight what's not significant in blue. Leading zeros are not significant. So not significant, not significant, not significant. What does that leave us with? It leaves us with 5, which is a non-zero digit, which is significant, and a trailing 0. So how many significant figures do we have? 2, which is the exact same as up here. So if you're never not sure, you can always switch it back and forth. If you prefer looking at significant figures in standard notation, you can switch your scientific notation to standard and vice versa, but they should match up.